Hey guys, welcome to another tutorial on FIS 309. My name is Ola Faith, and this time around we're going to be treating stocking density and other relations. Let's get started. Basically, in this tutorial, what we're going to do majorly is tackle some questions, because I'm going to show you how to answer some questions when you see them in exam, because I actually don't know how to categorize them. I don't know where to place them, so I just picked stocking density and other relations. So basically, I'm just going to work out as many questions as we can solve as possible. We work them out, so when you see questions like that, you know how to treat them. And I should have covered the pond construction too. I don't know why I just felt late to do this first. Then the next video will be the pond construction too. And I want to wish you guys a happy new year. So let's get started. Stocking density is actually the number of fish per area of a pond. The number of fish per area per square meter of a pond, and the formula for stocking density equals to the number of fish per the area of the pond. Number of fish per area of the pond. So having said that, stocking density, well, I just feel it is important to mention that at least the standard one is 5 fish per square meters. Should in case you see it, this is actually the standard one. So that's us by the way. Now let's try and treat questions. Like I said, majorly this tutorial is also treat questions. I'm bringing out the screenshot. I don't know if you guys are seeing this very well, but if you're not seeing it very well, I'm going to be calling out the question. So if you can't see it very well, you can follow from my words. Sorry that the screenshot is not as sharp. Okay, now there's a question that I'm seeing here. What is the amount of fish? This is the question. Should in case you want to follow, what is the amount of fish that can be stocked in 100 meter square pond if the stocking density is 300 per hectare? Let me just write out the parameters. So what amount of fish, that is number of fish that can be stocked in 100 meter square pond if the stocking density is 300 per hectare. Okay, now you need to know some relations. I believe this is where some relations comes in. So one of them is that you need to know that 100 meters times 100 meters gives 1 hectare. That is 10,000 meters square is 1 hectare. You need to know it. And 2.5 acres is equivalent to 1 hectare. So at least we need to know these ones. Let's now bring the idea into what we have here. So if the stocking density is 300 per hectare, which is actually too big, but it's just question, or probably the question is not correct, because the number of fish to the area of land is too small. Well, theoretically, 300 fish per hectare, if that is the stocking density. So what would be the number of fish that can be stocked in this place? Now for stuff like, if you have stocking density in this form, I would advise that you convert it from per hectare to per meter square. That is the best advice that I can give. So converting it to per meter, so you already know 1 hectare is 10,000 meters square. So convert 3 over 100, that's 0.03 fish per meter square. So this is the actual stocking density. Now, since I haven't known this, we can then come back to our question. If the stocking density from what we have, it is 0.03 fish to 1 meter square, isn't it? This is the stocking density from what we have gotten. Now, how many fish hex will stay in 100 meter square? That's the question now. Cross multiply, then we have 3 fish. All things being equal, if the question is correct, the answer should be 3 fish. So is anything like 3 there? Well, fortunately it is there, so the answer is A. Now that is stocking density. Let's scan for another question on stocking density. Okay guys, this is another question on stocking density, which is this. If you can follow me as I pen on it. What quantity of fish will be stocked in 10 meter square pond if the recommended rate is 500 per meter square? This is another question on stocking density. So let's get into the calculation. The question is what quantity of fish will be stocked in 10 meter square pond, so that the area of the pond now is 10 meter square pond. If the stocking density, that is that rate that they mentioned, is actually the stocking density, is 500 per meter square. This is another question. And how do you do this? You do it basically the same way you have done that. You do it basically the same way you've done the other one, but this time around, this one is not in hectare, so we are safe. You can just go straight. We have 500 fish to 1 meter square, and this one is actually too much. This life is not balanced. In the other question it was too small, now this one is too much. So let's continue. 500 fish.
Really, nigga?
500 fish.
Got him! Got him!
Let's continue. 500 fish per 1 meter square, and you're told to find the number of fish that can stay in 10 meter square of that pond. So cross multiply, x equals to 500 times 10, that's 5,000 fish. So the answer should be 5,000 fish. Let's check if it is there. Okay, it's actually there, 5,000, and that's that. Now, that's stocking density. I believe we've done enough of stocking density. Let's go into some other kind of relations. Like there's a question here now. What quantity of chicken manure do you require to fertilize 500 meters square of pond if the application rate is 200 kg per hectare? Now this is another question. What quantity of chicken manure is required to fertilize 500 meters square of pond? Now let's quickly write the question out. This time around, we want to find the amount of fertilizer in kg that can fertilize this area of a pond 500 meters square, and if the rate of application is what, 200 kg per hectare, the rate of application is 200 kg per hectare. Solving this is basically the same way the same way we did for the relation of that other one, the stocking density. It's the same way you also solve this. It's actually basically how to relate quantities. That's why I just termed stocking density and other relations. So how to relate other quantities, other things to get your answer. So this is the rate of application 200 kg per hectare. My advice is always convert it to meter square. Okay, 200 kg per hectare. We already know hectare is 10,000 meters square, isn't it? So convert, that's 0.02 kg per meter square, isn't it? So since we've known this, we can then say 0.02 kg goes to 1 meter square. Now how many kg would go into 500 meter square? That's what the question states. Cross multiply. X equals to 500 times 0.02, which is, I guess it's 10. Yeah, it should be 10. Sorry, I wrote 10 meters square. 10 kg. So that should be the answer. 10 kg is there. 10 kg there. Yeah, 10 kg is there. So basically, that's how you relate quantities. Now let's go to another question that requires relating quantities. And they said, what quantity of feed is required to raise a fish of 0.8 kg to the desired market weight 1.45 kg if the quantity of feed consumed is 0.05, if the quantity of feed consumed at 0.8 kg is 0.5. Okay, now this question is a little bit twisted. I'm going to explain. The feed required to raise a fish, the original fish weight is 0.8, but they want to raise it to the desired market weight, which is 1.45 kg. But at that 0.8 kg where the fish is currently, it consumes 0.5 kg feed. How many times would you feed it for it to reach that desired weight? How many kg would you feed it for it to reach that desired weight? That's what the question actually states. So the weight, this is the initial weight, which is 0.8, but we want to bring it to a market, the desired kg 1.45 kg, isn't it? We want to bring it to this desired kg, but at this point it consumes 0.5 kg feed. Now it's just simply relation. We've already gotten the relation. At 0.8 kg it consumes 0.5. Now what would it consume at 1.45 kg? What would you feed it to make it have this? Then x cross multiply. I get the answer. X, this is 0.8, x equals to 0.5 times 1.45. Then x is 0.5 times 1.45 divided by 0.8. Then you can quickly bring out your calculator. Then you quickly multiply 0.5 times 1.45. 1.45 divided by 0.8. This is 0.91. 0.91. This is the amount of feed it should consume. So let's check if it is there. Yeah, it is there. 0.906, still the same as 0.91. So that is another kind of relation. Now let's see if we can come up with another one before we end this. Okay, now let's treat this remaining question, then we call it a tutorial. And we don't call it a day, we call it a tutorial. Now let's pick the next question here. If 20 kg N is used to fertilize 100 square meter pond, what quantity of N will be required to fertilize 150 square meter pond? I believe this one is straightforward, isn't it? 20 kg 20 kg N fertilizer is used to fertilize square meter 100 square meter pond, isn't it? Now what quantity will be used to fertilize 150? What quantity will be used to fertilize 150? So I believe this one is straightforward. Just cross multiply and the answer is there. This is 100x equals to, by the time you multiply 20 times, this should be 3000. Yeah, 3000. Yeah, x will be 3000 divided by 100. So that means 30 kg and fertilizer is what would fertilize 150 square meter pond. So, and it is there in the answer, 30B. Okay, now let's go to this next question. There are 1000 catfish, 10,000 catfish with an average weight of 150 grams in a pond. I believe we need to write this question one after the other. So the number of fish in the pond is 10,000 fish, and their average weight is 150 grams. Okay, now let's go to the next. What will be the expected biomass after 15 days? Now we want to know the weight, the expected mass of all of them in that pond after 14 days. If the growth rate is 4 kg per fish per day. Okay, expected biomass. Let's quickly pen that down. What will be the expected biomass in kg? That is the expected mass of everything if their growth rate equals to 4 kg per fish per day. Okay, let's continue. And the mortality rate is 5% in 14 days. Mortality rate is 5% in 14 days. Now this question is Okisibe. Yeah, let me use that term, Okisibe. Okay, and actually it is simple. The question, what we are trying to get, is what you need to put your mind in. What we are trying to get is the total weight, the biomass. That is, if you sum all the weight of the fish after that 14 days, according to what they said, what will be the total weight of all the fish in that pond? That's what the question states. Now, number one, you have 10,000 fish in the pond, isn't it? 10,000 fish. Let's account that we have 10,000 fish and their average weight is 150 grams. 150 grams. But oh, sorry, growth rate should not be kg. It shouldn't be kg. It shouldn't be kg. This is a mistake. How can fish gain 4 kg in a day? It should be 4 grams per fish per day. This should be grams, not kg. The question is not correct. Well, either ways, now the growth rate is this. So we need to know the weight that it has accumulated in that 14 days. We need to know the weight that every fish in the pond, or before we even go to that point, let's know their current total biomass. At least let's know that. And the current total biomass is this average weight times the number of fish. Equals to times number of fish. So 150 times 10,000, that's 150,000. That's, in time we convert it, let's just convert it to kg. This is it in kg. Okay, this is the biomass currently. This is their biomass currently. Now let's know the amount of weight they have added, they would have added after 14 days. Now let's now come to this part. This is where we need this part. This is where we need this growth rate. Now one fish accumulates 4 kg in one day. Abi 4 fish 4 kg in one day. 4 grams in one day, sorry, one fish. So how many will that fish accumulate in 14 days? So how many kg in 14 days? Cross multiply, that's 4 times 14, and that should be 64. Sorry, times 4, 16. So 4 times 5, okay, that's 56. Maybe no calculation more. So 56 grams is the amount of weight the fish would have accumulated over time, isn't it? Over the period of the 14 days. So since this is the amount of kg one fish, but remember that they're not just one, there are 10,000 of them. So this is what one fish is going to accumulate in 14 days. So that's one fish picks up these grams in 14 days. So 10,000 fish should pick up what? So that's 56 times 10,000, that's 560,000 grams, and that's 560 kg. In the whole 10,000 fish will pick up this amount in 14 days. Okay, now this is what they will pick up in 14 days. Let's now add it to their original weight, because you know that they already have a weight before. This is just the weight they picked up as per feeding. Okay, so I'm sorry, I'm going to clean this place now. So their current weight, their current biomass now would then be plus 560. That's, by the time we had it, 0602 2060 kg. Yeah, but we can't stop here, and the reason is because the question also included that some of them died along the line. Some of them died, it's normal. Some of them died along the line, and you need to take account of those ones. You need to remove them from what we have here. So there are two ways to doing that. Firstly, let's try to know that 5% that died. Let's try to see what will be 5% of this one. 5% of this. So that will be, well, let's just do it this way. 20, isn't it? 0 cancel 0. So by the time you do this, that's 103 kg. 103 kg is the amount of kg that died along the line. So all you now need to do is remove it from the biomass. 206010357551. So this is the kg that is left after you have taken account of the mortality rate. Let's see, is the answer there? Yeah, A is the answer. A is definitely the answer. So this is actually one way of solving this mortality. Well, it's just this one is actually mathematics. Another way of doing it is, since 5% is the one that died, so that means it will be left with how many percent? 95%. So that means 95% of this is what we are actually going to work with. And if you find 95% of it, you get 1975 kg. And that's it. So basically it's about you trying to understand how to relate all those quantities. Try to find a way of knowing how to relate each of them so you know how to get your answer.